Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to find the area of a region bounded by two trig functions, different from the exercises that we had done. We have 2 sine x and tangent x, and in fact, x's are bounded below by negative pi over 3, which you can take it as a vertical line, x equals negative pi over 3. And also on the right, the region is bounded by x equals pi over 3, which is another vertical line. So even though I'm going to graph the region within the video together with you, I really want you to show what the graph looks like quickly, just to give you some heads up. So we have 2 sine x and tangent x, and blue is 2 sine x, and the purple right here is tangent x. And the region that is in between the graphs of f and g is split into two subregions, and in the first region at the left corner, as you see, the green region, the top border is in fact the purple, and the bottom border is the blue curve, which is 2 sine x. And in the second region right here, the bottom of the region is bounded by the purple curve, and upper part is bounded by the blue curve. So that's why we have to take care of each subregion with a different integral. Okay, and eventually, once we write the areas of subregions with different integrals, at the end we're going to take a sum, and that would hopefully represent the area of the whole green region here. All right, so again, have your calculator ready, because the first task is to graph these two functions and get a good outlook, and have your x min and x max to be large enough to start with. All right, so why don't we hit the road? Please go ahead and graph these two functions in your TI-84. Just plot two of them for, let's say, x min to be negative pi over 3 and x max to be pi over 3, just to see how the region looks like. Okay? You can pause the video at this moment and please work through that, and I'll show you in the next slide what the region looks like. Okay, here we go. So blue, here, the blue is 2 sine x. So let me just be precise on that. And the purple is tan x, okay? So this is tan x, okay? So interestingly, these are the intersection points happening at pi over 3. Okay. In fact, you can find those out. So you go ahead and solve 2 sine x equals tangent x. Okay. And this is equal to sine x over cosine x. Okay, so we write the description of sine tan as sine over cosine. Here we go. So I'm going to subtract it from both sides. So that I have this nice equation to solve. Okay, let me just copy this all the way to the new slide and work through that over there. So 2 sine x minus sine x over tan x is equal to 0. Sine x over cosine x, I'm sorry. Okay. So now let's try to solve this equation for x, and we have a common factor, sine x. Why don't we pull that out? 2 minus 1 over cosine x equals 0. Okay. We have two cases happening here. One is that sine is 0. Another one is that cosine is 0. And at this moment, since we're solving a trig equation, have your unit circle ready, because we may need that along the way to solve or to find x values here, okay? So one equation that I'm considering here is sine x equals 0. Another one is 2 minus 1 over cosine x equals 0. In fact, in the second one, if you multiply both sides of the equation by cosine x, you have 2 cosine x minus 1 equals 0. That implies that cosine x equals 1/2. Okay? So you may ask this question to yourself: whose cosine is 1/2, and whose sine is 0? Okay. So well, this is easy to find. If you use, by the way, your calculator T84 for finding arc sine 0, that would help. And in fact, arc sine 0 is already 0. And go ahead and check what arc cosine 1/2. So check what that is. Okay, I think you're going to get the pi over 3 out of your calculator. That's exactly what this point is. So let me just go ahead and write here. So this point here is pi over 3. And 0 is the intersection as well. But also 2 cosine x equals 1, meaning cosine x equals 1 over 2 should have another solution, which is negative pi over 3. Okay, which is very close to, that's a number very close to negative 1. And also this one, pi over 3, that's a number very close to 1. Okay. So there's a lot of calculations here to start with to find the intersection points. I knew that pi over 3 and minus pi over 3 were the intersection points provided us in the question statement, but we were supposed to sort of convince ourselves that these are the actual intersections. So here we go. So so the left-hand point here and right-hand point here are sort of like the intersection points over there. So now I'm going to find the area of two regions, because look at that. The area surrounded by 2 sine x and tan x is the combo of two areas, right? One is, I'm going to call it A1. The other one is A2. And going with our formula, to find the area in between two curves, we have the top, we have the bottom. But on the left-hand side for A1 is, you see that the top is tangent x and the bottom is 2 sine x. Whereas for A2, the top is 2 sine x and the bottom is tangent x. So we are talking about two different integrals. So for that reason, let me just have a newer slide, and then I'm going to work through A1 and A2 separately. Here we go. I have listed these two areas, and the formula again is the top curve minus the bottom curve, and we're going to determine the limits of the integral based on what x's correspond to within that region, within the corresponding region. So let's go back to A1. So for A1, as you see, the top function is the purple one, and the bottom function is the blue one. So tan x is the top, 2 sine x is the bottom. So tan x, and then 2 sine x. And it is the other way around. It should be the other way around for the second region and the corresponding area, right? So the top is 2 sine x and the bottom is tan. Okay. So 2 sine is here, and tan is here. Let's check the limits for A1 and A2. Well, x's for A1 are in between, like x's in this region are varying from negative pi over 3 to 0. So I'm going to go ahead and put negative pi over 3 here, and 0 to the top. Okay, top limits. Okay. And for A2, I have the lower limit to be 0 for that region, right? And the upper limit to be pi over 3. Okay, pi over 3 is, in fact, what I got as the intersection point. Let me just write maybe a little bit more clean here. So here, the point that I'm interested in is pi over 3. I'm going to go ahead and write here 0 and pi over 3 for the limits of the second integral. Okay. All right. So my task now is to evaluate each integral. Okay, so let's try to do that. So you have tan x, and 2 sine x. And if you have the derivatives and integrals formula card with you for the basic functions, that would be immensely helpful, because what I need is the integrals of tan and 2 sine x. Okay, please have that ready with you. So tan is integrated as let's see, negative ln, so let me just go ahead here, negative ln of the absolute value of cosine x. And 2 sine x is integrated as negative 2 cosine x, so that makes it plus. Okay. From negative pi over 3 to 0. And I'll apply the same trick here. So negative 2 cosine x plus ln cosine x. And this time the limits are 0, pi over 3. Okay? So make sure, again, that revisit the integration formula card for basic, for elementary functions. So you need to look at the integral of tan and sine. Okay? So tan is coming with the integral ln of cosine x with minus sine. Just don't forget the minus sign. Okay? So now let's calculate, let's evaluate A1 and A2 by the fundamental theorem of calculus. Okay? So let's plug in the upper limit. Minus ln cosine 0 plus 2 cosine 0 minus ln cosine negative pi over 3 plus 2 cosine negative pi over 3. Okay, let me just write A2 a little bit below. Okay. Now for A2, negative 2 cosine pi over 3 plus ln cosine pi over 3 minus negative 2 cosine 0 plus ln cosine 0. Okay, let me also close the parentheses. I'm sorry that I use different colors here. Here we go. To make them like different, so let me just make also this like fully white. There we go. Okay. And please go ahead and do the calculations here. You should get that A1 and A2 are equal. Okay. Okay. 1 minus ln2. Each A1 and A2 has the value 1 minus ln2. Okay, please convince yourself. Okay, and then going back to the original problem, this area surrounded by the graphs of 2 sine x and tan x in between negative pi over 3 and pi over 3. Let me call this like area. Total area, how about that? Is the summation of A1 and A2. And that is twice of what I found as the value of each integral. And that's 2 minus 2 ln2. And go ahead and find this number in decimal places, approximate it. It's 0.614. Okay. All right, so please do that calculation again by yourself by using your TI-84. And obviously don't use decimal places at this level. Okay, for example, here I have cosine 0, which is 1, and ln 1 is exactly equal to 0. Just use this type of simplification here rather than relying on decimal places. Or cosine 0 equals 1. Cosine 0 equals 1, so this is just 2, right? Right. So make sure like you simplify it on your own, and I think that makes it the end of the video. Thanks for watching, and if you have any questions or comments, please send those to my way. I will be more than happy to answer your questions as quick as I can, obviously. All right. See you in another video. Bye.